everyone. In this video, we'll be studying about symmetric circuit, right? How to solve problems related to this type of circuits. Great. I will tell you this via problem. Okay. Our problem is this. Here, capacitor is connected, right? This is our circuit. This is point A, point B. You need to find the equivalent between A and B. Okay, and the values of these capacitors are given as this is C, this is C, this is C, this is C. Okay, and all others are 2C, this is 2C. Okay, sorry, one more capacitor is connected here. 2C, 2C, 2C. This is also 2C, right? You need to find the equivalent potential between these. See, by looking at this circuit, you can find out one thing, that this part is almost symmetric with almost, or you can say 100% symmetric with this, the second part, or you can say the upper part is symmetric with the bottom part, right? What you need to do in this type of situations, you need to draw an axis of symmetry. Okay, see, this is your axis of symmetry, right? Axis of symmetry means parallel axis of symmetry, or you can say horizontal axis symmetry. And this line is perpendicular to axis of symmetry. What you need to apply here, what approach you need to apply is that the all points lying on the lines, means on this line, all the points, they will be having same potential. All points, this is a approach of doing this problem, right? All points lying on this line will have same potential, right? Okay, so if you consider this point as L, M is N, then L, M, N, they will be having same potential, right? If they will be having same potential, then you can remove these two capacitors, this 2C and this 2. Okay, but before removing, we are just redrawing this circuit, okay, in a better manner. See, this 2C, this 2C, they both are in series and they are in parallel with C. This 2C, they are in series and they are in parallel with C. This 2C are in series and they are in parallel with C. Okay, similarly this one is also in series and then in parallel with C. Okay, now we can redraw the circuit like this is the upper part, this bottom part. Okay, this 2C, they are in series. Okay, means their capacitance, equivalent capacitance will be C, and C are in parallel, so this will be 2C. Similarly, this will be 2C, this will be 2C, this will be 2C. and the inside ones are, this was C, 2C and 2C. Now these two you can remove from the circuit, okay, because this point, this point, this point, they are having same potential. So again redrawing this circuit, you will get something like this. You will get result like this, okay. Now what you are seeing here, this is 2C, this is 2C, this is 2C, 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 2C. Now this 2C and 2C, they are in series, so their equivalent will be C. Again this 2C, this 2C, they are in series, so their equivalent will be C. Again the bottom one, they are also in series, their equivalent will be C, okay. Now you can find the equivalent of this, it will be C plus C plus C, it will be 3C, means the C equivalent between A and B, it will be B. So with the knowledge of this, we have easily solved this complicated circuit, okay. This is basically a symmetric circuit. So in exams you need to look for the symmetry, okay. If you are if some complicated circuit is given, you need to think by this approach as well, that they may be symmetric, right. So this was one problem on symmetric circuit. One more problem I would like to tell you. This is a problem, try to do it on your own, okay. I'll tell you this. This is a capacitor circuit, okay. They are connected in this manner, and you need to find the equivalent between this point, this point, this is A, this is B, okay. You need to find C equivalent A, okay. So you can draw axis of symmetry here. This is axis of symmetry, because the symmetry on the left side is uh, you can say similar to the right one, okay. Now one more thing, that see, this is axis of symmetry, okay. Now you need to remember, you need to see that the approach of doing this problem is, see, firstly we'll find these captures, that this point and this point A and B, they are at same distance from the axis of symmetry, okay. This distance, this distance, this distance, and this distance, okay. Point, you can say small c and small d, they are at same distance from axis of symmetry, okay. So they will be having same potential. What approach we have applied in the last one, in the previous one, we have applied that the points which lie on the perpendicular to axis of symmetry, they will be having same potential, and the point which are equidistant from axis of symmetry, they will also be having same potential, means the potential VA equal to VB and VC equal to VD. So you can remove these two capacitors, right. Then your modified circuit will be like this, okay. We draw for this, your modified circuit will be just a second, look like this. Here your one more C, okay, and this is connected, it will be something like this, and on this side, right, okay. No, it will look like this. Okay, now you can see that this C, this C, this C, this, they are in series and they are also in series. Okay, so you can find their equivalent resistance. Okay, how? It will be C, 3 are in series, so it will be C by 3. This will be C by 3 on the left side as well, and this C. Right, now we have got a circuit like this. Here it is C by 3, here it is C, and here it is again C by 3. Right, so you can draw, you can do this problem. See, these 2 points, they are in parallel, means potential difference across this, it will be same. Okay, so the equivalent capacitance, it will be C plus C by 3 plus C by 3, that means 5C by 3. Okay, means the equivalent between A and B. So by this approach, you need to solve these type of problems. Practice more problems on symmetric circuit. Okay, there's a one equivalent capacitance, finding equivalent capacitance of a cube skeleton. Okay, you need to practice that as well. Okay, that is also very important.